Welcome, future scientist. Have you noticed how everything around you is made of combinations? Your breakfast, the air, even the soil. These combinations are called mixtures, and you use them every day. Understanding mixtures is like having a secret code for how things work, and how we can change them. Making tea, mixing juice, or preparing githeri, all are examples of creating mixtures. But what if you want to take them apart? That's where separation comes in, a key skill for any scientist. Separating mixtures is like solving a mystery. You look for clues about what's inside and choose the best way to pull them apart. Scientists use these skills everywhere, from cleaning water to making medicines, and you can too right at home. Ready to become a mixture master? Let's dive in. So, what is a mixture? In science, it's when you combine two or more substances without changing what they are. Each part keeps its own properties, like a fruit salad, where bananas, oranges, and grapes stay themselves, just mixed together, or sand and pebbles in a jar. You can still see and separate each part. That's the big difference between mixtures and chemical compounds. Mixtures can be separated because nothing new is formed. A mixture is a physical combination, not a chemical one. This is why we can take mixtures apart using simple methods. From the air we breathe to the soil under our feet, mixtures are everywhere. Remember, mixtures keep their parts separate, and that's the secret to separating them. Why separate mixtures? Because we often need just one part, like pure water, clean flour, or salt. Sieving flour removes lumps for smooth ugali. That's separation in action. Water from rivers is a mixture with dirt and germs. We filter and treat it to get safe drinking water. At salt farms, seawater evaporates, leaving salt behind for us to use. Separating mixtures makes things purer, safer, and more useful. It's a skill that keeps us healthy and helps us get what we need. Whether it's in the kitchen or a giant factory, separation is everywhere. That's why learning to separate mixtures is so important. Not all mixtures are the same. Scientists group them into two types, heterogeneous and homogeneous. Heterogeneous mixtures have visible parts, like fruit salad, sand and water, or githeri. You can see and pick out the pieces. Homogeneous mixtures look the same all the way through, like sugar, dissolved in water, or clean air. You can't see the different parts. If you can spot the bits, it's heterogeneous. If it looks uniform, it's homogeneous. Homogeneous mixtures are also called solutions. Try it at home. Mix soil and water, heterogeneous. Then salt and water, homogeneous. Knowing which type you have is the first clue to choosing the right separation method. This simple distinction is the start of your separation detective work. Every mixture you see fits into one of these two families. Let's use this knowledge to pick the best way to separate them. Time for our first separation superpowers, handpicking and sieving. Handpicking is just what it sounds like, using your hands to remove large, visible pieces, like picking stones from beans or rice. It's perfect when the parts are big enough to grab. When the pieces are too small or too many, we use sieving. A sieve has tiny holes that let smaller particles through, leaving bigger ones behind. Bakers sieve flour to remove lumps. Builders sieve sand to separate stones. Try mixing rice and flour. Then pour it through a kitchen sieve. The flour falls through, the rice stays. Handpicking and sieving are simple but powerful ways to separate mixtures. They're the first tools in your scientist's toolkit. Let's level up with filtration, a method for separating an insoluble solid from a liquid. Think muddy water. The mud doesn't dissolve, so we use filter paper to trap the solid and let clean water pass through. The liquid that comes through is called the filtrate. The solid left behind is the residue. Filtration is like a superfine sieve for tiny particles. Coffee makers use filters to keep grounds out of your cup. Air conditioners filter dust from the air. Even your kidneys filter waste from your blood. Filtration is everywhere, keeping things clean and safe. It's a key separation superpower for scientists and for you. Next time you see a filter, remember, you're seeing science in action. Ready for some science magic? Magnets can separate mixtures if one part is magnetic, like iron, nickel, or cobalt. Mix iron filings with sand, and it looks impossible to separate. Until you use a magnet. The magnet pulls out the iron, leaving the sand behind. This method is quick, clean, and works only if one part is magnetic. In recycling centers, giant magnets lift iron and steel from piles of mixed waste. Magnetic separation makes recycling faster and more efficient. It's a simple principle, with big, real-world uses. Try it at home with a magnet and some iron objects mixed with non-magnetic ones. Magnetic attraction is a true separation superpower. Our final superpower is evaporation, perfect for separating a dissolved solid from a liquid. Salt water is a solution. You can't see or pick out the salt. Heat the salt water, and the water turns into vapor, leaving salt crystals behind. This is how salt is harvested from seawater in giant ponds under the sun. Evaporation works when the solid dissolves completely and can't be filtered out. The downside? The liquid is lost as vapor, but you get the solid back. Try it. Let salty water dry in a dish and watch the salt appear. Evaporation is a natural, powerful way to separate mixtures. It's science, you can see. Congratulations, mixture master. You've learned that mixtures are everywhere and can be separated because their parts stay themselves. You discovered why separation matters, for clean water, safe food, and recycling. You learned to spot heterogeneous and homogeneous mixtures, the first step in choosing a separation method. You now have 4 superpowers: handpicking, sieving, filtration, and magnetic attraction, plus the magic of evaporation. These are real techniques used by scientists every day, and now, by you. Try these experiments at home and teach your family what you've learned. Science is about sharing and exploring together. Thanks for joining me. Subscribe to STEM Simplified KE for more amazing science adventures.